Hello, my name is James Fuller, and I'm here to talk to you about our experience building a Docker image for the popular command line network utility curl. Before we start, let's ask the question, have you ever used curl? Feel free to pile in on chat with your answer. To refresh our collective minds, let's just run a few curl commands. The first thing you could try is supplying a capital V, and that will show what version of curl you're using and what its release date was and what protocols and features that are enabled. Incidentally, you can also use the curl config command, which not a lot of people seem to know about. For example, if we wanted to know how this version of curl was built, we could look at the flags that it was built with. Right, let's try actually doing an HTTP GET. And I'm just using a test server, http bin.org, which I find useful. And when I do a GET on it, it's just passing back some JSON. We can always get a little bit more information about this call if I supply a lowercase v. And as you can see, we get the TLS handshake at the beginning, the request and response headers, and obviously the body. All right, so I'm not going to go too far into how to use curl, but maybe I'll show a few things that some people don't know. So if you ever wanted to write some C code using the libcurl library, you can always use the libcurl flag to emit an example C program. Now if we take a look at what we generated, and you can see we have a good starting point that uses libcurl to make the call that we originally did on the command line. Useful for learning. Another thing that I find people don't know about is the copy as curl feature that's supported in most browsers. So we go to a browser, and I'll go back to this test server, exactly where we made the first HTTP call. As you can see, it's returning back some JSON, and I've enabled developer tools. So if I right-hand click onto our original GET and do copy as curl, and then go back to our terminal and paste, you'll see that it's pasted a curl command which completely emulates what the browser did. That's pretty handy. And you're always able to use curl in fun ways. Let's say if you wanted to get some help on your favorite Unix utility, or let's say the weather, or if you're feeling, I don't know, depressed, you can always get the perennial favorite of the dancing parrot. Curl is also a library, which underpins a lot of language bindings, enabling developers to use curl in their preferred language. Written in highly portable C, curl supports many operating systems, running on a wide range of CPU architectures, supporting common protocols like HTTP, and many more protocols, maybe some you've not even heard of, providing a unifying facade over a lot of third-party dependencies. We know of a lot of companies using curl. Our apps use curl, our operating systems use curl, even our cars use curl. We see curl used not just in our mobiles, but a wide range of devices, from games consoles to vacuum cleaners. Curl running in embedded environments means we are pretty certain curl operates not just on laptops on the International Space Station, but at the furthest boundaries of computing environments. Okay, so a lot of you use curl. But let's ask the question, have you ever used curl on Docker? This presentation is about curl Docker, so let's run a few examples. And we're just going to supply the uppercase V like we did the curl examples. It's going to pull it from Docker Hub, and then run the command. and it has emitted the information banner. Let's do it HTTP GET. And that spit out some JSON. The entry point of the image allows you to peek in. So if we wanted to see what environment variables were set. And that's pretty much well it. Okay, now that we've framed things, let's get into the talk. As an agenda, I'll be doing an introduction. We'll talk about some design decisions and concerns, how we built the image, what we learned, what we might do next, and questions at the end. I'm a longtime programmer. Started off doing geophysics, working with lots of data about rocks and maps and that type of thing. I've worked for a bunch of companies you may have heard of and a bunch of companies you've definitely not heard of. I've worked for government entities. I've worked making commits to open source projects and also working on specs. I've done a lot of fun stuff during the 90s. I worked on fruit machines. I worked on a gambling website, apparently the first one, at least in Europe. I worked on the IBM Deep Blue versus Kasparov chess viewer. For the past 10 years, I worked for a company called MarkLogic, which makes a database, a multi-model database, a big data database. As an engineer working on the engineering team, we had lots and lots of giant clients. In my work with data in databases across networks with semantics, there was always HTTP involved. And I trend towards the functional programming side of life. I'm talking to you today about curl, and specifically curl Docker, a project I have a lot of time for. The motivation for me to get involved in this project was that I had already done the MarkLogic Docker image, and I sort of had flopped into wetware, that whole build chain to build and test an image and push to Docker Hub. You might ask at this point, who is curl? Well, that would be Daniel Stenberg. He's the original author, starting development on curl in the late 90s. Daniel would be the first to deflect any kind of praise onto himself and say curl is a project with thousands of committers. But really, he's our BDFL. That is, the benevolent dictator for life for the curl project. And here's our BDFL receiving a gold medal from the King of Sweden. And rightly so. So we know who curl is. Where does curl live? It lives, unsurprisingly, on a Git repo and GitHub. You'll have all the source and tests and build. We use Travis, Azure, Circle CI, and more for doing the builds and doing security scanning and fuzzing, etc., etc. Similarly, curl Docker lives on GitHub. It also has everything you need, and we just use Travis to build the image. And the main artifact out of that build is being pushed to Docker Hub under curl images curl. Let's try to answer why we need a Docker image for curl. Historically, the curl project has avoided getting involved in generating release bits. In fact, if we take a look at the releases, as you can see, there's an enormous amount of packages. The responsibility for building all these packages really has to be distributed to package managers who have the local knowledge of the platform they're building for. It'd be impossible for the curl team to try and manage generating all these packages on their own. The curl Docker image could then just be a special release target that the curl team just happens to manage. But that doesn't explain why our curl image is more compelling than anyone else's curl image. One advantage might be that developers want to have the latest version of curl, which is usually the best version of curl, addressing bugs, some of which can be urgent security issues. Package managers have to be conservative, we know that, which can mean that the curl version lags behind the latest release, sometimes far behind. Using the Docker image, developers can just use the latest curl Docker image without having to try and compile curl themselves. I guess the more nebulous answer is that it's unclear how developer habits and preferences are changing with Docker usage. We as a team want to get some direct experience managing a dedicated curl Docker image, learn a little bit, and see where the trip takes us. Now we can start talking about how we actually built the image. At the beginning of a software project, I tried to minimize scope to constrain the problem being solved. For me, the real job of design is to identify what not to do. Ultimately, avoiding writing software means we avoid writing tests and documentation and not having to fix bugs that we make. For the curl Docker image, we had to make a decision about what kind of image we want to build. Should we create an image that would be useful for inheritance? That is, maybe we try to submit it to Docker Hub's own standard library. And in that manner, we could use it internally in our project where we do already use Docker images. Or should we focus on a simple image design, purely for mass consumption and, just focused on end users wanting to use curl? The popularity of existing Docker images containing curl convinced me that we should take an incremental step first and then attempt, a more proper base image submission later on. This image should expose a minimal functional surface area, be as small as possible, and provide a foundation for future work. The second scope-related decision is should we create an ad hoc script for building and testing our image, or maybe adopt one of the swishy Docker build frameworks. Even though I've used Docker for 4 or 5 years, I consider myself still a newbie, especially when it comes to production usage. And as most of us curl people are crusty old C programmers, if we adopted a Docker framework, that would considerably obfuscate the work, at least for the short term, reducing the chance for reviewers comprehending what I wrote. So I opted to go down the simple sort of script approach. That does not invalidate adopting a framework later on, but keeps things simple in the initial stages. My personal definition of design concerns are those things that we must do to ensure cohesion in the system. That's on both a conceptual and operational level. The end goals for any software image are pretty common. You want to make it easy to use, you want it to run correctly and robustly in the Docker context, and I guess you want to make it easy to extend. There are other concerns I want to highlight. The first of which is testing Docker images. I put it under design because we wanted to build it into the build, and we had to make we had to think about the design of how we test things. So curl itself has a large and extensive test suite, but we also need a separate set of tests that verify the container contains what we want it to contain, and that curl operates in the container correctly. The other sort of overarching concern is ensure the Docker image is secure. That's for some reasonable definition of security. This specific paper showed that the biggest challenge is that of image sprawl. Base images get inherited by other images, which themselves get inherited by other images ad infinitum. This could result in your final image inheriting magnitudes more packages, which in turn increases the security surface area. The paper goes on and shows that on average a typical image in Docker Hub contains over 158 vulnerabilities, and then tries to identify the top packages. Anything we can do to mitigate this known risk will help make our Docker image more secure. Just a quick shout out of a few Docker specific implementation thoughts, no doubt obvious for most people in this audience. For us, multi-stage builds were just a logical evolution of what we did before with builder patterns, but with none of the complexity. And having a centralized Docker file definition keeps things simple. We definitely wanted to ensure we provided a multi-arch image so end users could run efficiently on their local architecture. and we were always keeping an eyeball on minimizing image size. A multi-stage build helps, but there were lots and lots of tiny activities for ham slicing and optimizing the size of the Docker image. Okay, the boring details are over, and we can finally start talking about how we built this thing. The build generates a single Docker image and is comprised mostly of a Docker file, a make file with targets responsible for building, testing, scanning, and pushing to Docker Hub. We pull a release tag version of curl that ensures we get a flavor of curl that has gone through all its rigorous testing. And then we use Travis to perform CI. We can take a look at this at the curl Docker GitHub repo. As you can see, we have a makefile, a Travis definition, and an Alpine directory that contains our Docker file. Let's just look at the makefile first. At the beginning, we just defined a bunch of variables to parameterize our build. For example, here are the options for building curl. Here are the architectures we're going to build. And then we have all the targets that build, test, push the image into the registry, scan, lint check, and clean and set up. We can drill down into the Alpine directory and see another makefile, which actually does most of the heavy lifting and just does the Docker invokes. I guess the interesting thing here is our security scanning runs another container that we've built, and I'll talk a little bit more later on that. And finally, the Docker file is pretty simple and straightforward, I hope. We're going to build curl the software first, so we do that work as builder here. And you'll see that we install our dependencies that we need, that curl needs. And then here's the magic recipe for building curl and running the tests, all the curl tests. And then once we've done all that, we're now going to make a clean image and then just bring the built artifacts over to this clean image. And finally, we set the entry point. How do we test the curl Docker image? Well, as part of building curl that we just showed you, we run its own tests. And then we use a handy utility called Project Atomic Dockerfile lint that parses the Docker file and tells us if there are any issues with it. That also provides some advice on best practice on constructing Docker files. We employ Google's container structure test to verify that the image contains what we want. That's pretty useful. And then finally, as a sanity check, we run the container itself. You can see yourself how all this test stuff works. Just go to the curl Docker repo and click onto the Travis build. And if we go into the log for the build, you'll see the area where we run all the curl tests. And if you continue further down, you'll see where we do lint checking. And finally, we'll see where the container structure tests are running and hopefully all passing. Our last sanity check of taking the built container and running it against our test server. To do some of the security scanning, we built a separate security container that uses the curl Docker image as a base, and then we layered on a few security scanning tools. The first of which is a virus checker. We use ClamAV and found it pretty straightforward. Second, we ran an old school rootkit scanner called RK-Hunter. We did try check rootkit, but ran into a lot of false positives on Alpine, so we decided just to stick with RK-Hunter. And then we used Linus, which performs a security audit on the whole system. And then if we passed all those, we used some well-known Docker engines, Trivis and Anchor, for scanning for vulnerabilities. And as we did with the test, you're always free to look at the Travis log to get a a feeling of how this stuff works. Here's the Trivis engine doing its thing and finding nothing, and then the Anchor engine doing its scans and generating a bunch of files. If we get vulnerability.json file, we know something's up. As for pushing the release to Docker Hub, it was very straightforward. We just used the Docker buildx push, and all that we had to make sure of it was the secret, that is the username and password, was appropriately and securely passed. Okay, what did we learn? Be conservative. Maybe this doesn't apply to all the projects on that have Docker images on Docker Hub, but for the curl project, this worked out very well for us. Open source tends to do development incrementally, and for us, that's works well for the curl project, and it works well for the curl Docker project. That is, we take off little bites of functionality and implement them, and then just iterate. Curl is a very well-known and popular utility, and what we don't want to do is make a release that breaks things. Next, keep it simple. I'm always reminded of Alan Perlis's famous saying. He was the guy who won the first Turing award. Anyways, he said something like, complexity precedes simplicity. That is, you can't just get simplicity by making all these bunch of simple things and then compose up, and thusly you'll have a simple interface or a simple program. Often what we have to do is boil down and refactor and take something that's a knotted mess into something simple. And for us, we just focus on a single image, which kept things simple. And then once again, I'm glad we didn't adopt a builder framework as our first step. And then there are other lesser lessons learned. The security scanning worked really well for us. We caught vulnerabilities in Alpine before we made releases, so that's enough to declare victory. We didn't release our multi-arch build as part of the first release, and in fact, it was nice that Docker had added experimental support for buildx, which makes it very easy to do multi-arch. And then Docker is great for development. I've been using Docker for 4 or 5 years, and I'm still a newbie. And that especially shows up when we're talking about using Docker in production. You just have to be more careful about it. This being open source development, we don't have a formal roadmap that we commit to. I have identified a short list of items that we might consider if the free time magically appears. Curl can be built with so many different configurations and backends. It's likely that the current curl Docker image may not be ideal for everyone. Maybe we should think about releasing an image with everything turned on, or with only certain feature sets enabled. Along the same lines, we could vary base image to offer curl Docker on distributions other than Alpine. So far, no one has asked for this kind of thing, and it's on the back burner. Some developers have asked for bundling useful utilities into the image. For example, we might install a JQ package, so you can work with JSON. That is, when curl downloads JSON, or we need to use JSON for posts. Generally, I have a neutral opinion on this, especially as it's easy to just create a new image that takes the curl Docker image as base, and then you can just layer on whatever package you want. Others may feel more strongly about that. And then we have the obvious more type enhancements, more architectures, more backends, more tests, and more scanning. And now that we've done our initial release and it's being used in anger out in the wild, we can start thinking about how to submit to Docker Hub standard library. And we do have an open issue tracking that particular item. Thank you for your attention. Much of what we learned was brand new learning for us. We are definitely not Docker experts, and I'm certain many in this audience might be thinking, why did they do it this way, or why didn't they try this? Please consider raising an issue or suggesting how we can do better on the GitHub repo issue tracker, and please do try out the curl Docker image. Lastly, a big thank you to the organizers for doing a great job organizing during difficult times and giving me a chance to go on about a project, curl, that I care deeply about. Thank you.